In this video, we're going to do a hypothesis test of a population mean when the population standard deviation is known. So this problem says a particular brand of tires claims that its deluxe tire averages at least 50,000 miles before it needs to be replaced. From past studies of this tire, the standard deviation is known to be 8,000. A survey of owners of that tire design is conducted. From the 28 tires surveyed, the mean lifespan was 46,500 miles with a standard deviation of 9,800 miles. Using alpha equals 0.05 is the data highly consistent with the claim. All right, so I'm going to just write down or type in a couple of things. So our hypotheses, so our null hypothesis would be, we could say at least 50,000 miles, or we could say just mu is equal to 50,000 miles. So I'll say, I guess at least, so greater than or equal to 50,000. So then HA, our alternative hypothesis, would be the other thing, right? Less than, right? The opposite of greater than or equal to would be less than. So mu less than 50,000. So that means that we're going to do a left-tailed test. And we need to notice a couple of things. So our population standard deviation, I'm just going to type sigma, is 8,000. And then they gave us, it's a 28 tires. So our N, our sample size is 28. And then X bar, the sample mean, is 46,500. And then standard deviation for the sample was 9,800, which we don't really need, but we can go ahead and put it. And that's supposed to be a lowercase s. 9. Okay. Well, let me change it back. Thank you. And then alpha, our significance level, is of course 0.05. Okay, so I'm going to go to StatsKingdom, and let me go back to, okay, so here's the home page, which is StatsKingdom.com, and the top kind of category of things you can do on this website are test statistic calculators. So that's what we want, and this is kind of foolproof. So these first two, notice it tells us it's testing the mean, and then it's either z-test or t-test, one sample, and the difference is whether or not we know our population standard deviation, and they basically tell us that too. So we do know ours, so we're going to use the z-test, one sample z-test. And we're doing a left-tailed test. Significance level is 0.05, so we can leave that the same. This other stuff, we're just always going to leave the same. And then, oh, I actually did this earlier, but I think, yeah, I had put in the wrong sample size. So I've put in like all the things already here, and it saved it for me. So sample average X bar, expected population mean, so that's the number we see in our hypotheses, and then this is the one that's important. If you don't even have that in there, it's fine. So, and it even tells us that, not mandatory. So I'll just go ahead and click calculate, and we can scroll down, and the first thing they tell us is the conclusion. So they tell us we're going to reject the null. And then here's our p-value. So I'm going to copy this and paste it here. So our p-value, which we often have to put into my open math, with however many decimal places they ask for. So that is about 0.01, which is less than alpha, 0.05. And so that means that we reject the null hypothesis. So our conclusion would be something like, at the 5% significance level, there is sufficient evidence to support the claim that the average tire lifespan is less than 50,000 miles. Okay, so that's typically all we're going to be asked to do, but let's look at some of the stuff they tell us. So they do tell us something called the test statistic, which is what's actually used to figure out the p-value, probability that x is less than or equal to that test statistic. That's what the p-value is, but we typically kind of just don't even worry about it. But if it is requested in a homework problem, there it is right there. And we're not going to worry about effect size right now either. So for our purposes, these first three, probably just the first two, are what we're looking for.